This is lesson 6.2, point-slope form. The goal today is I can write linear equations in point-slope form. So remember, we've been looking at these tools for writing equations, and we studied slope-intercept form last time. And standard form is going to be for some story problems later, and that brings us to point-slope form on the list. And the thing you need to know about point-slope form is what it requires. Well, it actually says what it requires. The word point means we need a point, and the word slope means we need a slope, and so it requires an ordered pair or point, and there's my x1, y1, and then I need a slope, which is m, and I'm simply going to drop those into the three spots with those letters and replacing those letters in the equation. So here's an example. What is the equation of a line that passes through the point 8, -1, and has a slope of -3/4? Well, this is my x1, this is my y1, and this is my m. So I'm going to take my form, my point-slope form, and I'm going to replace x1 with 8, y1 with -1, and m with -3/4. So it goes y minus, and then notice y1 is negative. So I'm going to have a minus and then a negative, which is going to make that a plus sign. And then slope is -3/4, and then parenthesis x minus, and then x1 is just 8. So we just write in 8, and we don't need to change any of the signs. Just leave it a minus. And you just wrote your first point-slope form. Okay? So how will you be given slope? Well, sometimes we give you a graph and you count the slope. Sometimes in a story or a sentence or a problem, they just say the slope is, and they tell you what it is. You might see m equals. Remember that parallel lines have the same slope. So we might say parallel to and give you an equation and you figure out the slope, or perpendicular to and you figure out in the equation what the slope is, and then you have to take the negative reciprocal for perpendicular. They might say the word rate or say the word rate of change. They might give you 2 points, and then you have to calculate your own slope. Okay, so there's lots of ways you're going to be given a slope. And there's lots of ways to give you a point. Like you could just pick a point off of the graph that's on the line that we're trying to write the equation of. It may just say a point that the graph passes through is, and they just give it to you, like -3/8 or something like that. They might say the y-intercept is. Well, that's just another point. And it's a unique point because the x-coordinate is a 0, and then there's going to be some value in there for y, okay? Or they might give you an x-intercept, and again, in that case, the y is going to be a 0, and they're going to put some other number in there for x. Or sometimes in a story problem, they're comparing two things. In this case, like they're comparing the cost per minute of a trip. So in that case, cost is y and minutes is x in your slope. So this would be like 6.75 per 7 minutes. And that would be our slope that we would use in our equation. Okay? So lots to learn here. So what's the equation of a line that passes through the point 6, -5, and has a slope of -1/3? Well, one of the things I want you to begin doing is figuring out which form is the best form to use for this problem. Well, clearly, if they've given you a point and a slope, point-slope form's the best. So this is our x1, this is y1, and this is m. And so my form is y minus y1 equals m times x minus x1. And so I'm going to fill y1 in. It's y minus, and then my y1 value is negative, and so minus and a negative. See that minus in the problem and that negative in the 5. They're different signs, right? I mean, they're not the same minus sign. They're two different minus signs together, which make a plus. Okay? And then the slope is -1/3. And then x minus, and x1 just happens to be 6, and there's my equation. I'll box in red this time. There we go. So you try the next one there. Stop the video, give it a try. See if you got it right. Well, here's x1, this is y1, and this is m. So y minus, the y1 value again is negative, so I'm going to put a plus 2. And negative 2/5 for m, and then x minus the x value is 5. There we go. What's the equation of a line that passes through the point 5, negative 7, and has a slope of 0? Well, that's kind of weird. Let's see what happens there. I know you guys are scared of 0. I don't know why. It's just a number. So I'm going to label 5 as x1, negative 7 is y. All our y values have been negative. That's not usual. It's not like they're all going to be negative. Look, the next one's positive. That's good. So, but sometimes, you just get in a rut and they're all the same, and then all of a sudden you think it's always going to be a plus, but it's not. So, okay, here we go. Y minus the y1 value is negative, and so we make that a plus, 7. And then slope is 0. And then you get x minus 5. Well, I can simplify this side. What's 0 times anything? Well, it's just 0. So I guess y plus 7 equals 0 is the equation, but we would probably want to move that 7 to the other side and write y equals negative 7. So what kind of a line is that? We just got done studying it. If it's a y equals, it is a horizontal line. And it passes through the y-axis at negative 7. So that's unique. You get a vertical line or horizontal line out of this one, right? So that's possible, that you can end up with an x equals or a y equals with these. Okay, where it's just some number, so it's either horizontal or vertical. And that's all because the slope was 0, and 0 times x minus 5 is 0. You guys try the next one there. Oh my, what is the equation of a line that passes through the point, and then there's my x1 and my y1, and then the slope is undefined. So what kind of lines have an undefined slope? Well, it's vertical lines. Vertical lines, there's no change in x. They're all rise and no run. And so if you have all rise and 0 run, that's division by 0, which is undefined. And so this is simply a vertical line, which is an x equals, and it passes through at negative 4. So it's just x equals negative 4. Okay? So when you see 0 slope and undefined slope, you know something's going on, right? Kind of tips you off there. All right, write the equation of the line. Well, in this case, we can't see the y-intercept. Like I can't tell where this crosses the y-axis, so I can't use slope-intercept like we learned last unit, or last chapter, or last section, right? I have to use something different. But I clearly can count my slope. So look, here's a point, and I can count the slope. Remember, to count slope, you start by going up or down. Well, you're going to start on the left. The leftmost point is this one here at negative 5. And you're going to have to go down 1, 2, 3, 4, and then you go to the right 1, 2, 3. So you went down 4, which is a negative 4. And then over 3 to the right, it's positive 3. And then I don't have my y-intercept here, but I have some points. Like I circled this point right there. What are the coordinates of that point? Well, it's 1, 2, 3 on the x, and it's negative 5 on the y. So let's just use that as our x1, y1. Or you could have used this point down here. It doesn't matter. You're going to get the same equation. Okay, so we're going to go y minus, and the y value is negative again, 5, so it makes a plus. And then slope comes next. Negative 4/3 x, and then minus, and then the x1 value is 3. And there's the equation. That's it. So let's look at this next one here. So again, I don't see the y-intercept, but I can do slope. So I'm just going to pick these 2 points to do my slope with. So this goes down to right 1. So my slope is -2 over 1, or -2. And then I'll use this point right here. So that point is 6, -4. So y minus, yet again, y is negative, +4, because it's a minus, and a -4 make a plus. And then slope is -2. And then x minus and a 6. Okay, so those are 2 equations there for that one. So some of you might push back on me a little bit and be like, if I had chosen a different point, my numbers wouldn't match your numbers. But what is the same is if you were to put this in standard form, the standard forms would end up being exactly the same. So even though you use a different point here than I used, like if you'd used this point right here at 5, -2, so then that equation would have been y minus -2 equals slope x minus 5. Well, if you distribute the -2, you get -2x plus 10. And then let's put it in slope-intercept form. Let's subtract 2. And you get -2x plus 8. Well, you get the same thing here. Watch. You're going to go y plus 4 equals -2x plus 12. And then you subtract 4. And you get y equals -2x plus 8 again. So they really are the same line. Okay? I know that the point slope forms can look like they're different, but when you put them in slope intercept or standard form by rearranging them, you see you get the same equation. Okay? So you guys try this one, stop the video, and try them both. Okay? And then start the video back up. All right, so on this one here, again, no y-intercept, but I got a couple good points. So leftmost to rightmost, so I'm going to go up 1, 2, 3, 4, 5, and over 1, 2. So my slope is 5 over 2. And then I'm going to use this point up here, and the x-coordinate is -2, and the y-coordinate is -6. So my equation is y minus -6 equals 5/2 x minus -2. So I write the minus, and then when I say if the value that I'm plugging in for y or x is negative, I say minus, and then I go negative, and I make my plus sign. Same thing over here. I did x minus, and then 2 was negative, so I made my plus sign, and then 2. Okay? It's kind of the mechanics I use to remember to do that. All right? So here's a point here and a point here, and I'm going to go down 2 over 3 to the right, so my slope is -2 down 2, right 3. And I'll use this guy right over here. -3, 1, 2, 3, +3. Okay, that's my x-axis right there. So y minus 3. Oh, finally, we got a y that's y value that's not negative. Y minus 3 equals m, and then x minus -3. So that one switches to a plus. Okay. All right, so there's assignment in Delta Math for you to work on.